Alright, so here we are at step number 34. Steps 34 to 36 basically go on about how to attach the servo that you're going to use for the steering. Notice that this is actually the front axle. So I've gone ahead, there was a servo plate right in this area here. I've gone ahead and removed that, and the reason I've removed this is so I can adjust the mounting point for the servo. Okay, so I figured it'd just be a lot easier. You can see here that I've got all the pieces laid out, of course, to put the steering servo onto the axle itself, and we're actually going to build the steering arm. Yep, this is the little tiny arm that's going to move the servo back and forth against this servo horn extension. Okay, so let's talk about servos for a second. Now earlier in the series I talked about using this spectrum-based digital servo. This is a S6020 surface servo. It's got 146 ounces at 6 volts. This really, if you guys are just out there having fun and you're doing more of a, you know, you don't have a huge budget, is a great servo to buy, okay? They still use these in 10 scale monster trucks and 8 scale buggies and truggies. Plenty of torque. But when you're competition crawling and you need something a little bit heavier duty, I've decided to go with the high-tech HS7950TH. Now you can see here, specs-wise, at 7.4 volts, it actually puts out 486 ounces of torque. Why is that important? Well, just imagine if these are rocks and we bring in a tire here and you get your tire stuck in those rocks, you're going to want to turn out. And if you don't have enough torque, you're only going to get a little twist instead of actually wiggling your rock crawler out of the situation. So let's have a look at this servo itself, okay? High-tech, this servo here, depending on where you get it, I found it anywhere from $160, you know, as low as $100, depending on where you look online. High-tech usually includes, in the higher-end servos, an aluminum servo horn, and of course all the attachments you're going to need for this beauty. Okay, so now you can see that I've actually assembled the steering arm. Okay, the whole assembly is done. You can see how when this moves back and forth, the steering, sorry, it's a little slippery, the steering moves back and forth, okay? Now I'm not actually going to attach this yet because I still want to make sure that my measurements on the front and back turnbuckles are correct. But just for a rough in right now to get started on the chassis, that's going to be just fine with me. Alright, so steps 37 to 40 really have to do with the contents of bag H and a few from plastic bag 1. Let's have a look at these side plates for the chassis. They are metal. You can see here that Axial has gone and cut their logo into it, but at the same time they also put in different positioner holes, so links and suspension and different things like that can be modified at will. Same with these end posts. Check it out, all these little different positions. So I've laid it out so it's splayed out so you can see how it would go together when it was lifted. I'm going to go ahead and start using some of the hardware that I have here to assemble the chassis, and we'll look at the final product. Alright, so here is what step 40 looks like all put together, okay? The chassis, the battery plate, the cross braces here, the post for the suspension, everything is in place, and you can see the chassis has come together. Next, it's time to move on to the receiver box and the bottom plate. As you can see here, these 4 holes line up with the 4 holes on the bottom of the chassis, okay, or the chassis floor. But you have to do some assembly first. This is a neat feature Axial's done. You can see here I have a small rubber washer or a rubber seal that goes around the receiver box. Okay, this is an attempt to help these comp crawlers have more of a splash-proof box. So if you're outside and you run through a creek or something during your competition, now you have a little bit more protection for your electronics. Speaking of electronics, that's exactly what I'm getting into now. Number one, I'm running a Futaba 4PK radio. It's a 4-channel radio, here in case you guys didn't see the other one or the other build video that this has it in. 4PK is a nice radio to have, really a Goliath, allowing you to independently control 2 ESC'S for the dig capabilities. We'll get into that as I'm configuring the ESC'S, but So I'm using the receiver from the 4PK. That's what's going to be going into the box here, having everything set up. But I wanted to introduce this at least because now it's time to do some of the FXR soldering and getting the ESCs mounted into the actual plate itself. Alright, so I'm sitting here working on my new Axial XR10 and I find that I'm in the position where I have to do some soldering. Now, a lot of people have written to me and PM me before about how to do soldering, and some of them in this build wanted me to kind of go into a little bit of detail on how to comfortably do it. Now, it was a bit of a challenge for me when I first started doing this as well, but once you have a few of the tips and tricks, it'll be easier for you guys just to take it on. So let's look at the ESC that I'm going to be doing. This is an electronic speed control. It's the FXR from Team Tekin. The speed control is basically the computer for an electric RC vehicle. Now, one of the things you have to keep in mind when using an ESC is normally they'll have a capacitor, okay? A capacitor is to prevent power spikes or surges, also holds power. So in the top of the ESC, this particular one, it has a battery positive and a battery negative post. It's the first two. Well, on the back of the cap, you'll notice one side is blue and one side is silver. This is to indicate negative and positive polarities. So each one of these pins is actually a negative and positive post. Now, I've already gone ahead and bent this the way I'd like. The FXR is going to be sitting upright in the XR10, the way I'm building it. So I'm actually just going to mount the capacitor straight out on the FXR. This way I can still see the LED display when it's powered and get to the functions. Okay, so now that you kind of have an idea about the capacitor, let's talk about the pieces for using in soldering. Okay, so for the application that we're using. I'm using something called flux. Just regular soldering flux. It's a paste, as it says here. You can see inside a little metal brush and a paste. This is basically an adhesive, okay? It cleans, it has a bit of an acid in it. It cleans the metal or the wires, and it also helps it be wicked into the wires, or to be drawn up the wires or the posts. So, the wires that I'm going to be using are different, multicolored. The reason this is of course we have two negative wires, which would be the blacks, and you also have color-coded power wires, so whichever ones you want. You can use red for battery and motor, or you can use red-blue for battery and motor. Your choice. Alright, so solder itself. I'm actually using Novak solder. It's a 3% silver mix. The silver in it gives it extra strength. So if you know things are going to get tugged or possibly, you know, roll over here and there with your rock crawler, I use silver solder. It definitely helps keep up the added strength. This here is shrink tubing for wires. We'll get into this, but it's basically a protective coat to stop from things short-circuiting or, you know, just being pulled. Of course, your regular soldering iron, there's lots of soldering irons out there. Careful, these things can get really hot. So, really straightforward here. Let's look at the actual soldering itself. So I've put the capacitor in there. I can always cut these extra wires after I'm done. We'll just take the capacitor off. What I'm going to do is take this paste and very carefully, just with a little bit each, cover the posts with some flux. Okay, make sure you don't have any foreign objects in there, and make sure that the flux is separated from the other posts. You don't want solder being drawn into another area. Okay, so once you're happy with that in there, make sure all the excess is wiped off. Make sure your polarities are correct. And in this one, I'm just going to place the cap in there and break out the solder. We want to pre-tip the soldering iron, and what that means basically is put some solder onto the tip of the iron to make sure that you have a nice little bubble going on. Really hot iron. Remember, you want to have a hot iron because if you don't have it, the solder really doesn't melt or stick to the flux that well. So now that I've tipped the solder, or the actual gun itself, you can listen to this. You'll see how it's drawn in, okay? Listen. Okay, now what that's done is it's melted the flux, and it's actually created, I don't know if you guys can see that in the light, it's done a solid connection, here, sorry about that, there, it's done a solid connection, and now there is a post with solder already on it. Will be ready for when I attach the wire. So let's do the other post quickly here. And you'll see it does the same thing. Careful not to get solder onto the other posts. Okay, so off camera I went ahead and snipped off the excess posts from the capacitor, and I added a little bit of extra solder to the outside of these heating posts, okay, or the soldering posts. I'm going to go ahead and with the pre-tipped wire that I've already used, I'm just going to heat up the end. Make sure that I have a good solid connection and some soldering flux on the actual pieces, and I'll just melt them together. Alright, so I've gone ahead and finished attaching the leads off of the ESC. I've put heat shrink all the way around to make sure everything's protected, and I've done these connections at a 90-degree angle, simply because in the XR10, the model I'm building here, it's going to be sitting vertical. Now, the radio that I run, being the 4PK, is going to allow me to use 2 ESCs in tandem, one for each axle, okay? You don't have to do this at home. You guys can actually use something called a Punk RC dig switch, or Novak has one too. Here's a quick look at the new and improved Punk RC dig switch that they've just sent me for this filming. Already has the Dean's connectors on there, has a really cool display light to let you know which ESC is engaged. But we are going to do a separate video on this to show you how, because this is not necessary with my FXR. All those folks that run Spectrum and 3-channel radios, definitely you're going to be wanting to use one of these switches. punkrc.com. Anyway, so we'll get on. I'm going to make another carbon copy of this ESC here. I simply have to do it to this one, and I'll be ready to mount it up and get on to the next steps of the Axial XR10. Alright, the final steps of the chassis have been completed. You can see here the frame has been set up, as well as the receiver box has been attached through the bottom of the frame. The receiver is now in place, as well as the 2 ESCs have been mounted. Now yes, this does deviate away from the instruction book. In fact, the instruction book has this plate that gives you the option of putting 1 or 2 ESCs and mounting them right in the middle. Now the reason I've gone with the way I have is because I've been able to install some Velcro and access each one of these ESCs individually without sliding this plate back out. Okay, so you can see that you don't have to do this. This is just something that I did, but it still gives me access to the mounting holes, as well as it gives me individual access here. So time to wire up the BEC, and we'll start attaching the axles.